All right, so we're starting chapter 4, and 4.1 is about inverse functions. So if you remember when we did functions, functions were as long as the x value did not repeat. Well, now we're going to look at what happens when the x and the y does not repeat, and that's called a one-to-one function. So every x value corresponds to only one y value, and each y value only corresponds to one x value. So a function is said to be one-to-one if the elements of a and b in the domain. So if a does not equal b, that will imply that the function of a does not equal the function of b. That is, different values of the domain correspond to different values of the range. So if we're going to decide whether a function is one-to-one, this first one is kind of straightforward because we know it is going to be one-to-one because it's linear. If I were to graph it, it just makes a straight line. So what we're going to do is we're just going to plug in, we're going to say if f of a is equal to f of b. So replace all your a's, all your x's with a's, all your x's with b's on each side. So that would be negative 4a plus 12 equals negative 4b plus 12. And then if I subtract 12 from both sides, it cancels out, leaving me with negative 4a equals negative 4b. Divide both sides by negative 4, and you get that a equals b. Therefore, it is one-to-one. Now, over here, because it's squared, you have to remember that when you take the square root of something, you get a positive and a negative. So, for example, let's just say that, let's just choose 3 and negative 3 for the x. So if I said f of 3 equals f of negative 3, if they come out to be equal, then that's not going to be one-to-one because the x can't repeat and match up with the same y value. So here the x isn't repeating, so we're good. The problem is that they're both going to give me the same answer, so that makes it not one-to-one. So let's just plug it in and look at the numbers. So we have 25 minus 3 squared, take the square root, and then we're going to have over here 25 minus negative 3 squared. So this is going to be 25 minus 9, and this is going to be 25 minus negative 3 squared is also 9. 25 minus 9 is 16, and the square root of 16 is 4. So since we get 3, 4 as a point and negative 3, 4 as a point, it's not one-to-one. Also remember when we were doing functions, we talked about the vertical line test. So if we had a graph such as this graph here, if we run a vertical line, that vertical line only touches our graph one time. That one touches it once, that one touches it once, that one touches it once, meaning that that is a function. But the horizontal line test, so we're going to run a horizontal line. So now if I run a horizontal line, do you see how it's touching my graph twice? So this means not one-to-one, because that means that this x value, whatever it is going to have this y value. This x value will have this y value. So x1 goes with y, x2 also goes with y. The y is repeating, therefore it's not going to work. All right, so here's just a couple of pictures to give you an idea, kind of what I just showed you. We have this curve function here, and if I draw a horizontal line through here, I'm hitting that graph 3 times. So each one of these x values has the same y value. So since the y1 repeats, it is not 1-to-1. It is a function, but it's not 1-to-1. So if you want to make yourself function, yes. 1-to-1, no. Now this one over here, this is a straight line linear function. Not only is it going to pass your vertical line test, it's also going to pass the horizontal line test. So this is, so function, yes. 1-to-1, yes. So one thing to consider is, in general, a function that is either increasing or decreasing the whole time. Increasing or decreasing for the whole domain, then this is going to be 1-to-1. So let me go back up here for a second with the pictures. So notice this first picture here, we're increasing, then we're decreasing, we're increasing. So since we're increasing, decreasing, increasing, it is not 1-to-1. And then in this function, notice that as your x's are getting larger, the y values are constantly getting smaller. So this one is decreasing the whole time. All right, so here's some tests to determine whether a function is 1-to-1. So if the function of a is equal to the function of b, that's going to imply that a is equal to b. This means that f is 1-to-1. In a 1-to-1 function, every y value corresponds to no more than one x value. To show that the function is not 1-to-1, find at least two x values that produce the same y value. Sketch the graph and use the horizontal line test. And if the function either increases or decreases the whole time, then it is 1-to-1. If it rises and falls, it is not 1-to-1. So just for visual, we have this graph here. So we are decreasing, and then we come over here and then we're increasing. So this is not 1-to-1. And then if we use something like this, here we are decreasing the whole time. So the y values, as we are coming in from here, our y values are constantly going down. So this is 1-to-1. Now, inverse function. So in a previous chapter, we did the composites where we plugged in a formula in place of x, and plugged in an equation in place of x. So the condition that f is 1-to-1 in the definition of inverse function is essential. Otherwise, G will not define a function. So let's look at this first example. So it says, let functions f and g be defined. Is g the inverse? So we're going to do f of g of x, then we're going to do g of f of x. So f of g of x, which is the cube root of x plus 1. So I'm going to use this function and replace x with what I replaced x with here. Because remember, this was f of x, and I replaced x with the function. So we're going to say that x plus 1, the cube root, so I'm replacing this x with this, and then I have to cube it because it says so, minus 1. When you cube a cube root, it cancels everything out, so we get x plus 1, and then we have the minus 1. Those cancel, and we're left with x. So now I'm going to do the same thing over here. Now I'm going to do g, and I'm going to replace x cubed minus 1. So now I'm going to take my g function, which is the cube root. I'm going to replace x with x cubed minus 1, then plus 1. So I have x cubed minus 1 plus 1, so these will cancel. Now I have the cube root of x cubed. Those cancel each other out, so we get x. So since we have the same answer in the end, that means they are inverses of each other. Now explain what the symbol f to the negative 1x, this is the inverse. So this implies the inverse of f of x. And I'm going to erase this. So x equals x. By the definition of inverse function, the domain of your function is the range of your inverse. And the range of your function is the domain of your inverse. So if you can find the domain of each one, then swap them and they're the range of each other. So let me show you what that looks like. So here we have a set of points. We have the function f, which is defined by these points here. So if I find the inverse, then I'm going to say, okay, we'll call it g. And you just take and flip them all. 2, negative 1, 0, negative 1, 1, 0, 2, 1, and 2, 2. That one really didn't switch. So now the domain is all the x values here. So if this is the domain, if these are all your domains, then that's the range of this function. And if we look at the range is the domain, oops, I should have used a different color, the domain of function g. Now, what I do see is that when I'm looking at my function of f, I look at my domain. I got negative 2, negative 1, 0, 1, 2. So my x's are good, they're not repeating. But then I start looking here and I see that negative 2 and 0 are both using 1, and then 1 and 2 are both using 2. So this is not 1 to 1. Okay, so this is not 1 to 1. So therefore it doesn't have an inverse without some type of parameter. And then here, now the 1 is repeating. So now x is repeating. So this one is not even a function. Okay, so remember, to be a function, x cannot repeat. And since x is repeating here, and then the 2's are repeating here, that makes the g is not even a function. So it's not 1 to 1. So this one is a function, but not 1 to 1. This one's not a function and not 1 to 1. So now if I look at this next one, I've got 3, 0, 2, 4, 1, 2, 3, 4. So this is a function. Oops. So this is a function and 1 to 1. So now I can write, I'll call the next one h. So this is 1, 3, 2, 0, 3, 2, and 0, 4. And this one is also a function and 1 to 1. So therefore, 1 to 1 and function So therefore it has an inverse. Here we have a table of information that's given to us, and we see that in the year 2014, there were 6 hurricanes in the North Atlantic. In 2015, there were 4. In 2016, there were 7, and so on. First of all, there is exactly one x value for every y value, and every y value has exactly one x value. So this is 1 to 1, therefore there is an inverse. So now I can put the number of hurricanes and the year. So 6 hurricanes in 2014, 4 hurricanes in 2015, 7 in 2016, 10 in 2017, and 8 in 2018. So this is a 1-to-1 function. Now, if we're talking about the equations of inverses, an inverse of a 1-to-1 function is found by interchanging the x and the y value of each of the ordered pairs like we just did. We just switched the x and the y. The equation of the inverse is defined by y equals f of x and is found the same way. So this is how this looks. So here are your steps. The first thing you're going to do is you're going to switch the x and the y. So we're going to switch the x and the y. Then you're going to solve your new equation for y. And then you're going to replace y with f inverse. All right, so this is what it's going to look like. So first of all, they gave me f of x equals 2x plus 5. So I'm going to write it as y equals 2x plus 5. So now that I have it written as an equation, I'm going to switch the x and the y. So now x equals 2y plus 5. Now solve for y. So I'm going to subtract 5 from both sides. So I get x minus 5 equals 2y. And then I'm going to divide the whole thing by 2. And I get that y equals x minus 5 over 2. So now I'm going to replace y with the inverse. So my answer is f inverse equals, so this piece right here is 1 over 2x, and this piece here is minus 5 over 2. And there is my inverse. So they're both linear, so I know it's going to be okay. For every x and y here, if we used a 1, just for an example, if I plug in a 1, I get 2 times 1 is 2, and 2 plus 5 is 7, so this point here would be 1, 7. And now here, this would be just the opposite. So if I plugged in a 7, which this would be super messy, it's going to produce the opposite point. You'll get 7, 1 as an answer. All right, now let's try this one here. So they've already got it in the y equals form for us, so we're just going to switch it and enlarge this a little bit. So now I've got x equals y squared plus 2. So now I'm going to solve for y. So I'm going to subtract 2 from both sides. And then I'm going to take the square root. So I get plus or minus the square root of x minus 2 equals y. So that means whenever I plug in an x value here, I'm going to have 2 answers for my y. Because when you take the square root, you get positive and negative values. So this is not 1-to-1 without there being some kind of parameter. So there's not an inverse. So for example, just to show you what I'm talking about, let's plug in 3. So if I were to plug in a 3, I would get 3. Actually, let's just do 4 so that we actually have a number. If we get 4 minus 2 is 2. So the answer would be, if I said x equals 2, then I would have plus or minus 4 minus 2. So plus or minus the square root of 2 equals y. So that means 2, nope. If I use 4, I have the square root of 2 and 4 negative square root of 2. So since the y value, since the x value is repeating, and I'm getting 2 separate y values as answers, this is not a function, or not a one-to-one function. So therefore there is no inverse. All right, and now this next one here, I'm going to turn this into y equals x minus 2 cubed. And then I'm going to solve. So now I've got x equals y minus 2 cubed. So the opposite of cubing something is to take the cube root. So I'm going to take the cube root of both sides. So I've got the cube root of x is equal to y minus 2. When you take the cube root, or when you take the square root, you're taking the symbol away. So keep that in mind so you don't stick that back on there by accident. So now we've got the cube root of x. I'm going to add the 2 over here. This 2 does not go underneath this. This is by itself. So that means the inverse is the cube root of x plus 2. And we can plug in any number for x because it's a cube root, so it can be negative or positive. So anything will work. All right, so now we're going to look at finding the equation of the inverse when it's rational. So first of all, x cannot be 4. So here the domain on this one is going to be from negative infinity to 4, and then from 4 to infinity. So that is the domain. So I'm going to rewrite this as y equals 2x plus 3 over x minus 4. So remember, the domain of this function is going to be the range of the inverse once we find the inverse. So now I'm going to switch my x and my y. So now x equals 2y plus 3 over y minus 4. And now I'm going to solve for y. So I'm going to have to multiply both sides by y minus 4. So now I've got xy minus 4x equals, and these cancel, 2y plus 3. Since we're trying to solve for y, we want the y's to be on the same side. So I'm just going to have the 2y come over here, and I'm going to move the negative 4x over here. So now that gives me xy minus 2y equals 4x plus 3. Now since both of these have a y, I'm going to factor it out. X minus 2 equals 4x plus 3, and then I'm going to divide by x minus 2. And that cancels out. Now that gives me y equals 4x plus 3 over x minus 2. So therefore the inverse is 4x plus 3 over x minus 2, and the stipulation is that x cannot be 2. So now the domain of this one is negative infinity to 2 and 2 to infinity. So now that means the range is the domain of my new inverse, and the range of my inverse is the domain of my function. So, graphing the inverse of a function whose equation is known. All right, so step 1, find some ordered pairs that are on the graph of f of x. So find some ordered pairs that are on the graph of f of x. So that are on the graph of your function, so of f of x. Then switch the x and the y. To get points on your inverse. Plot the points and sketch the graph. All right, so we can find the graph of an inverse from the graph of your function by locating the mirror image of each point with respect to the line y equals x. The line y equals x is just that one that goes diagonally across through the middle. So just kind of give you an idea of what I'm talking about. If we look at, say, okay, so here is the line y equals x. If I have a point 2, 6, so this is 0.26, then that means that 6, 2 is the mirror image across the line y equals x. So let's look at this one for an example. So we've got the line, here's our function, and we've got the 0.31. So that means the 0.13 is a mirror image across the line. So if I folded it over, that's where it would land. This point here's negative 4, 0 would be 0, negative 4, which would be right here. And now you've got, this is the graph of your inverse. If you have the point 1, 1, well, when you flip it, it's still 1, 1. So that one's not going to change, and that's okay. Here we got 2, 4, so now we're going to go 4, 2. And so now we've got this graph. So now this is your inverse. So just flip the x and the y. Same thing that you do on the equations. So finding the inverse with a restricted domain. All right, so we have f of x equals the square root of x plus 5. X has to be greater than or equal to negative 5. So it can't be negative 6 because that'll give you a negative under the square root, and now it's undefined. So the domain of this function has to go negative 5 to infinity. Okay, there is no negative infinity on this one because you have to start at negative 5. So when you're graphing it, what's going to happen is when you have this picture here, you're going to start here at negative 5, and it's going to look something like this. So if we were going to use the line y equals x, then that would mean if this were negative 5, 0, we would have to start at negative 0, 5. Negative 0, 0, negative 5. Let me say that the right order. That's where we'd have to start our new one. So let's see if we can get a mirror image. All right, so we're going to say y equals the square root of x plus 5. And we're going to switch the x and the y. I'm going to square both sides because that's the opposite of square root. So now I've got x squared equals y plus 5. And subtract the 5. So now what I know is the domain for this one is all real numbers. So remember, your domain of one function is the range of the other. Well, the thing is, this one here, the lowest you're going is 0. So this range right here does not match this domain. So therefore, the inverse doesn't exist unless you define it. So you would have to say that the inverse is x squared minus 5 as long as x is greater than or equal to 0. That's the only way that inverse would exist. But just in general, it does not exist because the range does not match the domain of the inverse. So if the function is 1 to 1, then the inverse exists. The domain of f is the range of the inverse, and the range of the function is the domain of the inverse. If the point AB is on the graph, then the point BA is on the inverse, and they have to reflect over the line y equals x. And to find the equation of the inverse, the x and the y interchange, and then you solve back for y, and that will give you your inverse. So our last one here, and this is kind of cool if you like decoding. So we're going to use this function here. So basically how it works is if you wanted to encode and decode, so here's your message: be my Facebook friend. So I know that B corresponds with the letter 2. So these are going to be my x values. So that means f of 2 is equal to 3 times 2 plus 1, which gives me a 7. E corresponds with 5. So f of 5 is 3 times 5 plus 1, which is 16. And you'd go through and you do so on, and you would get your new numbers. Now, you would send those numbers to whoever you're trying to keep a message from. You would send it to someone who has the code. So they would have the code, and then they would decode your message. So when you sent them all of these numbers, so you would send them 7, 16, and then the next number would be 40, and then so on and so on. So they would get these numbers. Well, they would plug them back in to the inverse so that it would spit back out these numbers so that they would know what letters to go with. So what they're going to do is you're going to take the y equals 3x plus 1, and now you got x equals 3y plus 1, and you're going to solve for y. So x minus 1 equals 3y, and then we're going to divide by 3. So y equals 1 over 3x minus 1 over 3. So now the inverse is 1 over 3x minus 1 over 3. So now they get these numbers here. So you did all of this, and you get your code. You send them the code. They take the code and they plug it into the inverse to decode. So for example, we're going to replace x's with 7. So this is 1 over 3 times 7 minus 1 over 3. 7 thirds minus 1 third is 6 thirds. 6 divided by 3 is 2. So they know the first letter is a 2. So they go up here and they're like, okay, 2, so the first letter is a B. And then they do that same process to all of the numbers that you sent them. And then they will be able to spell out, be my Facebook friend. Have a great day. See you next time.